Okay, let's try to do an example. X squared. Let's try plus 5x plus 1 equals 0. We want to solve this. By the way, I could tell you right off the bat, we're not going to be able to factor this because we have a 1 and a 1. Is there any way we could take two 1s and get 5? No, so I'm not even going to try. But I am going to try to complete the square. So what do? We take b over 2. That's going to be 5 halves. And b over 2 squared. That's going to be 5 halves squared, or 25 over 4. And what we do is we add and subtract the b over 2 squared. So we're going to get x squared plus 5x plus 25 over 4 minus 25 over 4 plus 1 equals 0. I know these three terms here together are going to give me x plus b over 2 squared. I have to combine this. This will give me a minus 25 over 4 plus 4 over 4 equals 0. So I get x plus 5 halves squared. Well, what do I get? I get minus 21 over 4 equals 0. Or I could just move that over to the other side. And now, I know that this is equal to plus or minus the root of 21 over 4. Or I get x is equal to minus 5 halves plus or minus the root of 21 over 4. I'm done. I could simplify this a little bit if I wanted to. I could write it like this, but the answer I had before is correct because I know that, hey, the square root of 21 over 4 is the square root of 21 over the square root of 4, and I happen to know that the square root of 4 is 2. So that's an example with using completing the square to do something. I certainly wouldn't be able to factor this in order to solve it, so this is a great method for solving a quadratic of that form.